You start learning about solving with one equation in like 3rd grade. You really do. And instead of calling it x, though, remember they put a blank in your math textbook? It was like 3 plus blank equals 5. And you're like, oh, what is it? It's 2, because 3 plus 2 is 5. That's the beginning of algebra right there. So you've been learning algebra since 3rd grade. But now we take a little bit of a more algebraic or systematic approach, and we use placeholders and variables and not blank lines, right? So that's the only major difference here, and the fact that we're going to be looking at things where you have to divide and multiply, not just add and subtract. Okay, so we're going to talk about that in the second piece of today. The second piece is going to be isolating a variable in an equation. And I'm going to get to that when we get to that point, but it's solving with all variables and no numbers. So we'll see how that plays a role, and that's what differentiates this class from a regular math class. These extra things that we're doing. So like that number line question that seemed really complex at the end, right, the part B, that's really the differentiation. You're not going to see that in a regular math class, and you're not going to see the second part of this in your traditional math class. You won't see that until like junior year of math if you're on the regular level. You guys are in the honors class. So you're going to be pushed to go at an accelerated pace and to learn more difficult things for that reason. Don't let it, discourage you and make you feel like you don't know it if you're having trouble. Make it something that you actually work toward, right? It's not going to be a class where you're like, oh, I get everything in this class. Everything's pretty easy. Some of it will be review, but we extend upon that review, and that's what we're going to do in this section. So the first word we're going to talk about, now I talked about vocabulary in this course. Vocabulary is huge. The word root. The word root, you have learned as the word solution a lot. It's the same thing. Solution and root, for the sake of this context with equations, is the same thing. It's the solution to an equation. It's what makes the equation true. The root is what makes the equation true. So when you solve for x, the answer you get, you've called it the solution. I'm going to use the phrase root as well. Okay, root as well. So let's look at this first example here. Now, based on your math teacher you had in 8th grade, you could take different approaches to solve algebraically. I'm going to show you the most direct route that I think, at least. In certain problems, there are little shortcuts along the way. So if this problem, take a look at it real quick. If this problem had, instead of a 7, let's say this problem had a 6 on that side, well, then it would make sense to reduce both sides. Again, take a look up. I want to talk about this. If this were a 6 and this were a 3, I could then just divide both sides by 3 and the 6 would become a 2, right? If it were divisible. But it's not. So it doesn't make sense to divide by 3, because then you would get 7/3. Then you would have to distribute 7/3. Then you'd have to get rid of the thirds. So in this case, it makes sense to do what first? Distribute. But there are cases where you don't want to distribute. And you want to look at your coefficients, and maybe they reduce if this is a 4 and this is an 8. Or if this is a 5 and this is a 15. So there's a possibility that you don't always distribute. Distribution is not always the answer, even if it looks like you should. In this case, it is the way we want to take it. So let's go ahead and do that. So to distribute here, I get 6x plus 15 equals negative 7x minus 63. That agreed so far? Yeah? Distribute to each term. Next step in algebra is to do what? And again, there are multiple ways you can approach it this point. Doesn't matter, either one is fine.
Isolate the variable.
Isolate the variable? That's absolutely. So what's the first step you would take?
I would keep 63 positive side, put plus 63 and add it to the 16.
Okay. Can I ask I got you. Can I ask, would anyone do, and that's fine, would anyone do anything differently? That is definitely one way we can do it. And it's not better or worse than the other way. What else could you do?
I would subtract 15 from both sides because you would end up with a lower x.
That's fine. Subtract 15 from both sides. That works. You can do that to start. What else can we do? Do we have to start with the constants? No. We can start with the variable terms. Right? So what else can we do? So you're going to Sean? No. Sam? Yeah. You could move the 7x over to this side to make it a 13x. Or, last but not least, what's the other step we could do if we wanted to? Probably not the ideal route.
Subtract 6x.
Yeah, you can subtract 6x, which makes that a negative 13x, right? Now, it doesn't matter whether numbers are positive or negative, but in my experience, students do better when numbers are positive, right? I mean, I'll be honest, it really is the truth. They don't matter. There's no difference whether it's positive or negative in the solution. But I personally think you do better when you keep numbers positive. So I would personally, in this problem, probably start by moving the 63 over, but then when I move the 6 over and we'll get a negative anyway. Or I might move the 7x over to make that 13x, but then I would probably have to move the 15 over, which would make that negative. So in this problem, no matter which way you approach it, you're going to get a negative part we have to deal with because the answer itself is negative, actually. Okay, so it doesn't matter which way you take. I'm going to start with adding 63 only because I think Jimmy started with that one. He was the first one to raise his hand. So this becomes 6x. In this case, we have plus 78 equals negative 7x. Because the 78 is already over here, I'm going to move the 6x over. Even though I know it's not necessarily, going to make it easier because I have a negative x now, but because the 78's there, I'm going to move the 6x over. I still have 78 here, and I've got negative 13x. So far, so good? Please ask if not. Make sure you ask if not. That's our last step here. What do we do at the very end? The very end is probably again. Divide by negative 13. What do I get when I divide by negative 13? Negative 6, yeah. Okay. If we didn't know that one, we could do a little long division. Do not rely on your calculator, please. Your test will be half calculator, half no calculator. Okay? So the problems that don't involve a calculator, you need to be able to do some simple multiplication and division either by hand or in your head. Is that clear? Okay, we have to be able to do that. Do not rely only on your calculator for your arithmetic. Jimmy, what's up?
On homeworks, are we allowed to use calculators?
Yeah, you can, but I wouldn't become too dependent on it, Jimmy.
But just like for simple math?
Sure, but this is pretty simple that you should be able to do in your head. This one, you know what I mean?
Yeah.
But if you had a problem that was like 127 divided by 6, yeah, you're going to get a weird decimal. So in that case, you leave it as 127 over 6. Or you take the calculator and get the approximation or the repeated decimal. Yeah? Fractions are always good though. So, granted, 78 over 13 is not reduced, so that's technically not simplest form. But 127 over 6 is as simple as you can get. You cannot, no. You cannot divide 127 by 6 or simplify that at all. So if my answer was 127 over 6, leaving it like that is absolutely fine. You don't have to give me the decimal approximation. Yeah? Is that clear? What else?
This is a question. I know it was not a Regents school, but
Mm-hmm.
will we be taking
No. No, you don't take a Regents exam in school. You most likely would want to, and I think you should, end up taking the subject test in math. So for the SAT, you take the SAT English and then math. There are also specific subject tests for what's called Math Level 1 and Math Level 2. So I would recommend you take the subject tests, like Math Level 1 you can take after 10th grade, and Math Level 2 probably after your 11th grade year. Because if you're going to study math or science in college, or if you really enjoy math and science and you're going to be in that field, it looks good for college just to see good scores in those areas. So the Regents is not a mandatory thing for all schools. It's just public schools. It has to do with funding and stuff. Questions on this? What could I do at the very end? What could I still do if I wanted to make sure my answer is right? Olivia? Yeah. Plug negative 6 back into where? To where? But specifically which line? The first, always, right? We know that? We don't plug our answer and check it in the last line because clearly, if I take negative 6 and plug it in here, it's going to work, right? Because this line is based off of this answer is based off of this line. But if I made a mistake up here and I'm using this line and checking it here, it's not going to show up. So you always check your answer in the original equation. Second one, I'll give you about, a minute to work through it. We'll go through it together. And you don't have to write the same thing I have. If you do it differently, it's fine. My first line, I distributed it 2. And now I distribute the negative. You can do it all in one step also. Right? So this first line could really just look like this. Then I'll collect terms. When you get to the line I have on the board, pause. When you get to the point I have at the same time, just pause. Why did I tell you to pause? John.
Because if you were to add 8 on both sides and subtract 3h from one side, both sides you remain with 0 equals 0.
You get close, not 0 equals 0. Nina? It's negative 8 equals positive 8, or 0 equals 16. Be careful there. It's not 0. That's if they were both positive 8, right? But you're on the right track. The key is this, and I said John. You're John, right? Yeah, and that's Sean. Okay, sorry. So Sean, sorry about that. So the key is this, Sean, as you said, the 3h's definitely cancel, right? Because they're on both sides. So they automatically drop off, which leaves me with negative 8 equals 8. Is that true?
No.
No. Therefore,
No solution.
very good. I'm hoping you learned this in your middle school. If not, write it down. When you get to a line at the end of a problem and the variables all drop off and you get a statement that is not true, we call this in math a contradiction. A contradiction statement tells us that there is no solution. Yes.
You said something about 0 equals 16. That's what I thought.
Yeah, because if you move the 8 over, right? And that's this point. And it's the same thing, Gus, because watch what I do. I'm going to add 8 to both sides, right? And I get 0 equals 16. Still, is that true? No. So at this point in time, you could have stopped. Or here, you could stop and say, contradiction.
Yeah, because I did I got to the point where it's 5h minus 5h equals 16. So I did it a different way. So I never got to negative 8 equals 8.
But you got to 0 equals 16, right? Exactly. So whenever your variable term drops off and you get a false statement, there is no solution. What's another way of writing no solution?
A 0 with slash.
A diagonal line. Good. What's another way of writing no solution? That's a not equals. Not equals. I like it though, but that's not this one. Have you heard of an empty set? I'll give you that one. The squiggly brackets with nothing in them. Because sometimes you get multiple answers to a problem. And we're going to see that this year where we have several answers. And you might use what's called set notation. And you might have answers of like 7, 5, and 2. So you put 7, comma 5, comma 2 inside of this little set. But if you put a set with nothing in it, or a 0 with a line through it, or the word no solution, those are all interchangeable things. Okay? We should know this kind of terminology. We should know this. Let's move on. Example 3. I'll give you again 30 seconds to a minute. Process through. When you get to a problem, you're like, "Ooh, this is interesting." Think about what you got. And I know some of you guys are seeing this and jumping on to the next one, which is great. Like if you got this one already, go on to example 4 while I'm doing this, okay? And make sure you fully understand it if you're going to move ahead. When you get to this step, you can pretty much stop. You can pretty much stop because you're going to probably drop off the 6m next, and you end up getting negative 9 equals negative 9. But that was the same thing as this line, right? What do we call it when we have an answer that is the same, or an expression that are the same on both sides, Clark? And as a result, how many solutions do we have, Clark? Help me out. Infinitely many. Infinitely many. Any number works. Try it. Pick a number for m. Go to this line right here and pick a number for 1. Let this become 6 minus 9. This becomes 6 minus 9. Pick a number m equals 2. 12 minus 9 equals 12 minus 9. No matter what value you put in for m, it will always work, correct? So we say that this is all real numbers. Anybody know the symbols for all real numbers, how we write that? Have you seen that before?
Yeah.
Have you seen it before? It has to do with a weird little E kind of thing? Yeah.
Is it like capital R and like an I connected?
Kind of like that. Very good. Yeah. You would say M is in the set of all real numbers. It's just notation. This means in the set of real numbers. The only time you're going to really see me use this symbol when your answer is all real numbers. It's the only time I'm going to really utilize this much. And this means it's in the set of. Okay, but all real numbers. Jimmy.
So, I got to this step. What I originally did was negative I added 15 to both sides.
Yeah.
So that and got
6m plus 6 equals 6m plus 6. And inherently, isn't it the same thing I got?
Yeah.
Yeah. Because the 6m plus 6, as long as you have an identical expression on both sides, your answer is all real numbers. Doesn't matter what line you used or stopped at, it matters that you have the same on both sides.
I'm trying to.
Yeah, no, that's correct. All right, let's take a look at example 4 here. Example 4 says the formula that relates the height h in feet of a rocket launched t seconds after firing with initial velocity v0 given in feet per second is as follows. Determine the initial velocity of the rocket if it reaches a height of 40 feet after 2.5 seconds have passed. So you've got your first look at word problems here with function notation, okay, with functions involved here. We're going to really study functions later in the year, but I'm giving you a little preview of that because I'm only using variables and not necessarily the h of t function. So, what am I given in this problem? What am I told, Gus? Good. So 40 feet is the? Good. And what is this given as, Gus?
Seconds.
Very good. So how did you figure it out? Yeah. Use the, what's after the number? The units. The units really help you. If I see 2.5 seconds, seconds represent time. If I see 40 feet, feet represents a height. And what am I trying to find? I'm trying to find the initial velocity. Determine the initial velocity, which is represented by this symbol, v0. The 0 is a subscript. It just means initial. That's all it means. It's not a number or anything like that that we have to worry about. It's not multiplying. So this problem becomes 40 equals negative 16 times 2.5 squared plus v0 times 2.5. All right, let's go through the process. Square 2.5, multiply by negative 16. Right, square 2.5, multiply by negative 16. So what do I get as a number for this? When I square 2.5 and multiply by negative 16. What do you get? Negative 100 plus v0 times 2.5. If it's not correct or if Ina made a mistake, let us know because I'm approving your statement because I don't have the number in front of me. So next, what do we do? Now that the equation looks like this, how do I solve this standard equation? And what's my next step? Yeah, move the 100 over next. We got 140 now. Notice I'm not showing the work anymore. You see what I'm doing? You can show or you don't have to show. It's an honors class. If you can move 100 over in your head by adding 100 to 40, just write the next line down. You don't have to show plus 100 plus 100. Do we see that? Honestly, at this point in your life, you should be able to do this without worrying about showing that step. And then finally, divide by 2.5. What does that come out to? What's 140 over 2.5? What do you got, Sam? Sean?
56 feet per second.
What is it, Sean?
56 feet per second.
Very good. Good answer with units. I like it. Do people agree or disagree? Is that right? 56? Olivia, give me a nod. I got 2 yeses. Lily? Awesome. Okay. So once I get enough yeses, I assume that we all on the same page for that. Look at the lines. Make sure, if you're not sure, that you ask a question. Any concerns about this problem right now? Any issues you have? Anything you're wondering about? Yeah, we're all good on this one? Okay, let's press on. Let's continue. All right, here's the next one, and this is where we're going to get into like higher level algebra thinking. What we did so far, honestly, could have been done in your 7th grade class, probably. Maybe you have to leave it to 8th grade class, but you've done what we've done already. I know that. This might be a little bit new. So it says, note, in the next example, when solving an equation in terms of other variables, consider those other variables to be constants. So let's look at the first problem, or first part of this problem. The volume V of a cone with a height h and a radius r is given by the following formula. Okay, there's the formula. I'm not giving the value of the radius, I'm not giving you the height, I'm not giving you the volume. We're not taking care of numbers here, we're looking at variables. 1/3 is just a coefficient. The problem says, solve this formula for h. Solve it for h. So here's what I'm going to do. I'm going to do the solution on the left, but as I do it, I want you guys to be thinking, what would you do if everything were numbers? And what I mean by that is this. Imagine, I'm going to do this, so this is part A. I'll do it in red on the other side. Imagine instead of V, I had a number, 20. Pi is a number, 1/3 is a number, and instead of R, let's say I had 5. Okay, so this would be the equation if I think of everything as numbers, except for what I'm looking for, right? What am I trying to solve for? I'm trying to solve for H. So I know that I can't plug in a number for H, because that's my solution what I'm looking for. So when you take your steps on this side, do it the same way you do this side. Tell me, what would your first step be if you were looking at the problem in red? What would your first step be in red?
I would divide both sides by 1/3.
Which is really the same thing as multiplying by?
Multiply by 3.
So let's say that as the first step. Okay, that is definitely the first step. Multiply both sides by 3. So I would do that over here. This would become 3 times 20 equals pi. And I'll leave 5 squared alone because I know I can't square the r. I'm just going to leave it the way it is. I know it's 25. I'm leaving it. So I would multiply both sides by 3. Please do that on the side over here. Let's go ahead and multiply both sides by 3. The next line becomes 3v equals pi r squared h. I want you to see the analogous nature of what we're doing. Right? This is with numbers. This is with variables. It's the exact same problem. Pi r squared h, pi r squared h, 3 times the volume, 3 times the volume. I'll take it.
Why did you multiply 3 by h on
Where are you at?
the top?
Here? Remember, I multiplied both sides by 3. This 3 and this 1/3 cancels. You see that? And you're left with pi. I can show the cancellation, but I was just leaving it. So the 1/3 cancels with the 3 right there. I'm showing the steps over here a little bit more. I didn't really show it as much over here because these are all numbers and it's a little easier to see it. But with variables, the steps kind of can help sometimes. Now, what would I do next? How would I get rid of a multiplier of pi 5 squared when I get h by itself? Yeah, divide both sides, in this case, by what?
Pi h.
I want to get h by itself, so I want to touch h.
Just pi and then 20.
Yeah, and then the 5 squared, 25. So I would inherently divide both sides by pi, divide both sides by pi, but I'm also going to divide both sides by 5 squared, so I can do that all in one step. Please get used to this. You can do these things in one step. On the left side, I'm going to do the same thing. I'm going to divide by pi r squared. Divide by pi r squared. Well, the pi r squareds cancel. The pi 5 squareds on the right example cancel. I'm left on the right with h equals 3 times 20, which I know is 60. I'm leaving it for a reason. Times pi over pi times 5 squared. Well, with the algebra, with all variables, I'm left with the same exact expression. Just take a look and go step by step. If you're not seeing it, recognize this is 3 times the volume, which would be 60, over 25 pi, right? You would write that as a 25 normally. But look at the nature of the problem. 3v, 3v. Pi 5 squared, pi r squared. It's the same exact approach I would take if I had numbers. Same exact approach I would take if I had numbers. So eventually, I want you guys to be able to do this without having to write an example of numbers. I don't want you to be writing an example of numbers every time. But when you're stuck, ask yourself, what would I do if everything was a number? If everything was a number except for the variable of interest. If you're solving for h, you can't put a number here. So leave that as a variable. But make everything else a number and ask yourself the question, what would I do? Let's do part B together. We're going to solve the same formula, but now we're trying to solve it for r. Okay, now we're trying to solve it for r. So I'm going to start part B here. The formula is the same. Okay, it's 1/3 pi r squared h. What's my first step? How do I get rid of that 1/3, Clark? Multiply by 3 on both sides of the equation. The 3 and the 1/3 cancel each other out on the right side. The left side becomes 3v. The right side, I'm left with pi r squared h. That's the same as the last one, isn't it? So far, it's the same step. So far?
I was going to say the next
Yeah, good.
The next step will be dividing everything by pi r h.
I like, because you're thinking to get pi by r by itself, right? But then r would have an answer with r in it. You can't have r equals 2r like that. It doesn't work. So forget the r, just do the other piece. So tell me what you do and I do.
Divided by pi h.
Good. Divide both sides by pi h. Divide both sides by pi h. 1 second, I know you have the answer. On the next line, it becomes 3v over pi h. The pi h is canceled. Take a look at what I'm doing on the right side. I'm showing the cancellation, leaving me with r squared. Now, first name again? Nick. Nick, it's really important that you see what I meant by that. Do you see how I didn't divide by r there?
Yeah.
Because if I had divided by r, you would get r equals 3v over pi rh. R can't be in the answer when you're solving for r. Okay? Just keep that in the back of your mind, guys. You cannot solve for a variable and have it in terms of the same variable. So the last step to get r by itself, Clark, square rooted. And John, you had your hand up first. I want to ask you, maybe you, because you had your hand up. When I take a square root of an answer, John, how many answers do I get?
2.
Yeah. What are they, John? Whenever I take like square root of 25 is 5 or? Very good. Remember when you take a square root, you put a plus or minus in front of it. So this becomes the square root of 3v over pi h with a plus or minus out in front. That's the answer for r in terms of v and h. Listen, you can practice this a million times over and not get tired of practicing. You can make any equation you want. Use the perimeter of a circle, or the circumference formula, the perimeter of any polygon. Make up an equation. 2x plus, write this down, seriously. 2x plus 3y, right? 2x plus 3y all over z equals w. All over z, the whole equation, equals w. So again, write down 2x plus 3y, that whole thing over z equals w or something else. And just solve it for one of the other variables. Practice it. Practice on your own. The first time through, solve for x. The second time through, solve for y. And you can practice this infinitely many times. Okay? Yeah, so your homework tonight is only section 7. Okay?
And it was due day 2, correct?
And since I don't see you guys tomorrow, tomorrow's day 1, this is not due until the following day. Correct. Recommendation, listen, recommendation. Tonight you don't technically have homework because this is not due until day 2, right? I'll see you tomorrow, day 1. So what might you want to look at tonight?
Problem set.
I'd probably start with the problem set tonight and get into a little bit of it. Okay? I do. You're supposed to turn it a little bit, right? So, right? 3 people turn this in. Yeah, anytime you have a hard copy, you gotta give it to me. I've never collected that stuff, so I assume everybody does electronic. If you're going to do a hard copy, that's fine, but give me a starting period.
Do you ever write the problems if you do a hard copy?
No, I mean, the original, you should always write the original equation if it's an equation you're solving, but if it's like a word problem that you're like going through, you don't have to write the entire thing.
Okay, so it could basically be just our first step and then edit it?
Correct.
Got it.
Yep. Again, if you want your quizzes, come by after school. I'll have your quizzes ready for